Okay, hello and welcome back. In this video, we're covering section 6.4 on the division of polynomials. So we'll see two different situations and two kinds of processes for dividing two polynomials. The first will be dividing by a single monomial, and then how to divide a polynomial by a larger polynomial. So let's start with the simpler first case, and then continue from there. So we'll first see dividing a polynomial by a monomial. Just to quickly review, a polynomial is something that has multiple terms, so like x squared plus 3x plus 1, whereas a monomial just has a single term, so just x or like x cubed or 3x squared would all be considered monomials. So we're just dividing by a single term. So what we're going to utilize is the fact that if we do have, let's look at a simple case, something where we just have a sum of two terms on the top of a fraction, a plus b over d. This fraction is essentially division. We're saying a plus b divided by d. Well, this can be split up into a over d plus b over d. You can split it up into two separate fractions. And this works if we have any number of terms in the numerator, so like a plus b plus c plus any number of terms over d. Those will all split up into separate fractions for however many terms we have in the numerator. It's kind of like a reverse of adding two fractions together. Usually we're going this way where we get some common denominator and then we can write it as a single fraction. But we can go the other way too. We can split it up. And that's a useful technique in a few different situations. So that's what we will utilize. That's the procedure that they're defining here. They say to divide a polynomial by a monomial, divide each term in the polynomial by the monomial and simplify. So just take a look at their example. They have 6k squared plus 10k minus 18, and it's all being divided by 2. So they end up splitting up each term into being divided by 2, and that reduces everything. So let's practice with these two in example 1. We're going to divide, in the first case, we have 24x squared minus 8x plus 20, all divided by 4. Still technically a monomial. We just have a 4, there's no x's, but that's like just our constant term. So that means we can write this as the 24x squared over 4 minus 8x over 4 plus 20 over 4. And then let's just reduce each term. So 24 divided by 4 is 6, so that will become 6x squared. 8 divided by 4 is 2, so minus 2x. And then 20 divided by 4 is positive 5. Part B introduces a variable in the denominator, so we'll just have to think about how things will simplify. So we have 12c cubed plus 54c squared plus 6c, all divided by 6c. So let's use this same process. We can write each of these divided by the 6c. And now we'll divide by our number, but then also think about how the variable will simplify. It will cancel, since we just have c to the first power, it'll just cancel with one of the powers in the numerator. So for example, our first term, 12 divided by 6 is 2. and then c cubed over c to the first power. We can see that 1c is going to cancel with one of these powers. That's one way to view it. Or if you remember, if we're dividing some common base that has two exponents, you would subtract the exponents. So we can do 3 minus 1, and that will give us our correct power. So c squared. For our second term, 6 goes into 54 9 times. Then we have c squared on top and c on the bottom. So we'll have 1 left over. That'll cancel with 1. I'll write it like this. And then our last term, we have 6c over 6c. So those will both cancel. It'll just reduce to positive 1. So just split it up into multiple terms and then reduce whatever is left over. All right, let's look at example 2. They write it a little bit differently. They're using the division sign, but we have the same situation. So we have 6a minus 7 minus 36a squared plus 27a cubed. And we're going to divide this by 9a squared. Notice the left one is all kind of mixed up. It's helpful to write it in descending order, meaning we start with the highest power and then reduce from there. So I'm going to write this as our highest power is the a cubed, so we have 27a cubed minus 36a squared. Then we have a 6a to the first power, and then minus 7. And this is all being divided, so I can write this on the top of a fraction with the denominator being 9a squared. So let's split this up. It's being divided by a monomial, just a single term. So that means we can write this as 27a squared over 9a squared minus 36a squared over 9a squared plus 6a over 9a squared minus 7 over 9a squared. Now let's simplify. 27 divided by 9 is 3. And then, oh, and this should be a cubed here. I think I wrote squared accidentally. So we have 27 divided by 9 is 3. And then a cubed over a squared. These 2 will cancel with 2 here, and we should have 1 left over. So just a to the first power. Then 36 divided by 9 is 4, so minus 4, and then we have a squared over a squared, so those will just cancel out. Now here, we have to just reduce this 6 over 9. We can divide them both by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And then, now notice we'll have an a left over in the denominator. We have 1a up here that will cancel with 1 in the denominator. So we should get plus 2 in the numerator over 3 times a in the denominator. If we did this as a subtraction of powers, we have a to the first power and then a to the second power on the bottom. So 1 minus 2 gives us negative 1, a to the minus 1 power, which places it in the denominator. And then our last term we'll have to just leave as minus 7 over 9a squared. There's nothing here that will cancel. So in this case, we don't get a polynomial. Remember, we defined a polynomial as having only positive powers. We technically have some negative powers here. Minus 1 power and a minus 2 power, putting them in the denominator. So if you divide a polynomial by another, you may not get a polynomial as the result. Oops, let me come back here. Sorry, jumping around. Okay, but in general, if you're dividing a polynomial by a monomial by just a single term, you can split it up into separate fractions and then reduce. So let's see how to divide whenever we don't have that case. So when we're dividing a polynomial by another one. The text first has us just divide two numbers in long form using long division. And the reason why we're doing this is that division of polynomials will follow the same general procedure as long division. So let's quickly review how this would be done. We're going to do 854 divided by 3. So usually start by looking at what's on the outside, and I think 3 times what, or how many times can I multiply 3 by something to be equal to or less than 8? So I'd think, okay, I would multiply 3 times 2 to get 6. So notice this is 2 times 3. I'm writing it here. And then I subtract these results. So 8 minus 6 is 2. Then I drop down the next term. So these general patterns will be the same when we're working with polynomials. Now I think about what I want to multiply 3 by in reference to that 25. Go have to do 8. 8 times 3 is 24. So I write that result here, then subtract, get a result of 1. And I keep moving down terms until I run out. Move down the next term, I get a 4. I'll have to do 3 times 4, which will give us 12. Subtract these results, and I get 2 as the remainder. So the result is 284 with a remainder of 2. So let's see how this would apply to polynomials, and we'll follow the same kind of general structure of thinking about what we should multiply, writing that number up here, multiplying these two numbers and writing the result below, and then subtracting, getting the result, bringing down the next term, and just repeating that process until we make it all the way through. So let's just look at our first one, example 4. We have 5x squared plus 13x plus 6 divided by x plus 2. Notice we no longer have a monomial in the denominator. So I'm going to write this like a long division problem. I put the numerator under the division symbol. So 5x squared plus 13x plus 6 is being divided by x plus 2. In general, when we do this, we want to write what's underneath here in descending order. We already have that for this case, but we'll probably see an example where it's more mixed up. So we write it in descending order. So let's start doing this division. So in general, I'm going to just look at this first term on the outside and then the first term on the inside. I see x, and then inside I have 5x. So the question I'm going to ask myself is, x times what? X times some number gives me 5x. I'm thinking about what I need to multiply this outside number by in order to get this inside term. Equals 5x squared, I mean. X times what gives me 5x squared? So what should I multiply here? Well, I definitely need the 5, and I have x to the first power, so I would want to multiply by 1 more. If I did 5x times x, that will give me 5x squared. So once you find out that thing that you want to multiply your first term by to get this first term, I'm going to write that up top here, 5x. And I'm writing it over the term that has the same power of x. You have the first power. Okay, once I have that written, I'm going to multiply these two together. Basically, I'm going to distribute this to both terms if I imagine this being in parentheses. 5x times x will give us the 5x squared. So I'm going to write that beneath here. Then 5x times 2 will give me positive 10x. So I'm going to write that right here, plus 10x. So I distribute it through. Now I'm going to subtract this, just like in our long division. So I usually write this with parentheses and then a subtraction symbol. And I'm just going to go term by term and subtract its like term beneath it. So we'll start with 5x squared minus 5x. Those cancel out, which is what we want. That's why we chose the 5x. So that will give us 0. Then I have 13x minus 10x. So 13 minus 10 is 3, and it should have an x attached. So I do my subtraction, then I bring down the next term. In this case, I'm bringing down this plus 6. And then the process starts over again. So now I'm looking at the first term on the outside, always just looking at that term, and then the first term here. And I'm asking myself, x times what? X times something will give me 3x. Well, in this case, I just need a 3. So I'll say plus 3 here. Now I'm imagining taking that 3, I can write the workout here too, and multiplying by x plus 2. That should give me 3x plus 6. So that's what I'm going to write down here. And notice when I subtract, I'm subtracting the same thing. I'll just get 0 as my remainder. Both terms will cancel out. So if you have a 0 remainder, I can just write, let's restate the problem. I can say 5x squared plus 13x plus 6 over x plus 2 equals this. This will be our result, 5x plus 3. So this is long division of polynomials. So again, I start by looking at my first terms. I think about what should I multiply this outside term by in order to get my inside term. Once I find out what that is, you place it up top, then distribute it through. You write the result below. Subtract everything and then bring down the next term and then repeat that process until you run out of terms to drop down. So let's see a few more examples because it's a pretty intricate process, but once you do it enough times, you start to pick up on the pattern. Okay, so now we're given this big division. Notice that the polynomial on top is not in descending order. So let's rearrange it and place it under a division symbol. I see I have 15n cubed. I have a minus 17n squared. I have a minus 28n to the first power, and then plus 41. Okay, and this is all being divided by 3n minus 4. So let's start that process again. I'll look at this first term, 3n, and I'm thinking, what do I need to multiply it by to get 15n cubed? 3n times what gives me 15n cubed? Well, to make the 3 a 15, I should multiply by 5. And since I have one n and I want 3, I should bring in 2 more. So 5n squared. You could also view this as a division. I could take what's inside the 15n cubed and divide it by this first term on the outside. And here, notice I get the 5n squared. That would tell me what term I want to place up here. I'm going to put it over the n squared term. So now let's distribute the 5n squared to both terms on the outside. So 5n squared times 3n gives me the 15n cubed. This should always be the same because that's how we're choosing this number. So if when you're writing this you get something different, that might be a sign that maybe some error was made. Okay, and then we'll multiply the 5n squared by a negative 4, so that will give us minus 20n squared. And then this is all going to be subtracted. So the first term should always cancel out. 5n cubed minus, or 15n cubed minus 15n cubed gives us 0. Now we just need to be careful with the double negatives. I have negative 17n squared minus negative 20n squared. So that double negative might even be helpful just to write it out over here. Negative 17n squared minus negative 20n squared. Well, that will become negative 17n squared plus 20n squared. So that should just leave us with a positive 3n squared. That's what will remain here. And then now let's bring down our next term. So 3n squared minus 28n. Do my side work over here. So we just repeat the process. I have 3n, and I think, what do I need to multiply it by to get 3n squared? We just need another n. So I can write plus n. You can also do that division trick too. I have 3n squared. I can divide by that first term on the outside, 3n, and that tells me just n to the first power remains. That's what I want up here. So let's multiply that n to both of these terms. 3n times n gives me the 3n squared. And then negative 4 times n will give me minus 4n. And then let's subtract. The first term cancels, and then I have negative 28 minus negative 4. So that would become negative 28n plus 4n, which will be negative 24n. These double negatives are where this becomes tricky and where a lot of errors can be made, so just want to be extra careful. Now let's drop down our next term, 41. And then repeat the process. 3n times something should give me negative 24n. So I need a negative for sure. And I know 3 times 8 is 24. So negative 8. And I already have the n, so we don't need to add another n in there. So multiplying that through, negative 8 times 3n gives us the negative 24n. And then negative 8 times negative 4 will give us a positive 32. And this will be subtracted. So negative 24n minus negative 24n is 0. That cancels out. And then 41 minus 32 gives us a positive 9. There's no more numbers to drop down, so this will be our remainder. We'll have a remainder this time. So let's see how we can write our result. we're doing this big division. Let me just write out what was given to us. Minus 28n plus 15n cubed plus 41 minus 17n squared. All of this is being divided by 3n minus 4. So this will be equal to our result on top, so the 5n squared plus n minus 8. But we still have this remainder, so I'm going to write it as plus the remainder over what we were originally dividing by, 9 over 3n minus 4. So if you have some remainder, you just write it as your last term over what was originally on the outside, what you were originally dividing by. All right, let's see one more example. Actually, we get two more, I think, in this next one. Yeah, we'll see some special cases here, I think. So we are asked in part A to divide x cubed plus 64. We're dividing that by x plus 4. So notice there's some missing terms. We have x cubed. We don't have an x to the second power or the first power. So when I write this division, I have to put in little placeholders for those. What I mean by that is I'm going to write this as x cubed plus 0x squared plus 0x to the first power plus 64. And this is all going to be divided by x plus 4. So we just need these little placeholders in order for this process to work out. So it's still in descending order, just with any missing terms replaced with a 0. So now let's continue as we have before. So I'll look at my first terms, x and x cubed. Well, I need to multiply x by x squared to get x cubed. So I'm going to write that here. And then multiply it through. So x squared times x gives me my x cubed. And then x squared times 4 will give me 4x squared. So now I will subtract. First term cancels, and then I have 0 minus 4x squared. So this will show up as a negative 4x squared. And then I'll still drop down my next term, even though it's a 0 term, plus 0x. And then let's repeat the process. So x times what gives me minus 4x squared? Well, I want the minus 4. And I have 1x, I just need to multiply by another x to get x squared. So then when I distribute minus 4x to both terms, I will get my minus 4x squared. And then minus 4x times positive 4 will give me minus 16x. And this is being subtracted. The first term cancels, and then I have 0 minus negative 16x. The minus negative becomes positive. So this will give me a positive 16x here. And let's bring down the next term. So plus 64. I have x. I want to make it 16x, so I just need to multiply by positive 16. When we do that, 16 times x is our 16x. And then 16 times 4 will give us positive 64. So when we subtract this, everything will cancel. We'll get 0 as a remainder. So I'll say x cubed plus 64 divided by x plus 4 equals x squared minus 4x plus 16. So again, here, if you're missing any terms, like we didn't have a x squared term or an x to the first power term, just give placeholders in your division and then continue the process normally. All right, let's look at part B. So it looks like it is in descending order. 4, 3, 2, 1. Yep, so let's write this out. I have t to the fourth power plus 3t cubed plus 6t squared plus 11t plus 5. And this is being divided by t squared plus 2. So notice we're kind of like missing terms on our outside term now. So I won't put placeholders there, but I will whenever we're working on the inside here, and I'll show you what I mean. But let's start like normal. I have t squared, and I want to make t to the fourth power. So that means I need to multiply by another t squared. So I'll write that here above the squared term, and then distribute it through. T squared times t squared gives me t to the fourth power. I don't have a third power term, so I'll just say plus 0 t cubed. I guess I could write the placeholder on the outside and you get the same result. Then t squared times 2 will give me 2t squared. So plus 2t squared. Notice this is lining up now, so it's time to subtract. The first terms will cancel. T to the fourth minus t to the fourth is 0. Then I have 3t cubed minus 0t cubed. So that will show up as 3t cubed. Then 6t squared minus 2t squared. So 3t cubed plus 4t squared. And then let's drop down our next term, 11t. Then repeat the process. I have t squared, and I want to make it 3t cubed. So I need the 3, and I need another t. So plus 3t. Multiply that through. 3t times t squared will give me 3t cubed. I don't have a t squared term. My next thing would be plus 6t. So I have plus 0t squared. And then let's subtract. First term will cancel. Then I'll have 4t squared minus 0t squared. So 4t squared. Then 11t minus 6t. So plus 5t. And then let's bring down our next term, plus 5. Now, last time through, I have t squared, and I want to make 4t squared. So I just need the 4. Plus 4. Multiply it through. That will give me 4t squared. 4 times 2 is 8. That means I have 0t to place in. This will be subtracted. First term cancels. 5t minus 0t is 5t. And then 5 minus 8 will give us negative 3. We've run out of terms, so this will be our remainder. So let's write our result. I'll just write what this will be equal to. We have everything up top, t squared plus 3t plus 4. Plus our remainder, which is 5t minus 3, over what we were originally dividing by, the t squared plus 2. And that will be our result. So it's a pretty extensive process, this long division of polynomials. But we are repeating a process as we go through. So once you get one first like iteration, once you get through one step, you're really just doing that same process again, doing the same process again until you run out of terms to bring down. We just saw these special cases where if you're missing some terms, we just need these placeholders. And we saw them show up here as well. But otherwise, the process is still the same. Right, I think they give us a summary of dividing polynomials. So it says, remember when asked to divide two polynomials, first identify which type of division problem it is. The first one is simpler. If we're dividing a polynomial by a monomial, like what we saw earlier, just split it up into a bunch of fractions. Just divide each term and reduce your results. And then if we're dividing a polynomial by another polynomial containing two or more terms, we take the route of long division, which is what we've been working with here. So yeah, if you can, take the simpler route if you just have some monomial. I would definitely seek to do that first. All right, so we've found the wrong section here. That was our previous one. So we divided a polynomial by a monomial, and then a polynomial by another polynomial. That'll be it for this video, and I'll see you next time.